Lesson 18, Analyzing Residuals. I can use a residual plot as an indication of whether the model will use to describe a relationship between two numerical variables is an appropriate choice. So in this lesson, we're going to be looking at residual plots and scatter plots and determining whether or not it is a linear graph or a nonlinear graph, curved graph. If you've not done so, open your book to page 121. The previous lesson shows that when data is fitted to a line, a scatter plot with a curved pattern produces a residual plot that shows a clear pattern. Okay, so curved plots show patterns. You also saw that when a line is fit, a scatter plot where the points show a straight line pattern results. In a residual plot where the points are randomly scattered. Example 1, the relevance of the pattern in that sentence. Oh, nope, missing something there. The relevance of the pattern in the residual plot. Our previous findings are summarized below. Okay, so if you have a scatter plot that looks like this first one, the residual plot, okay, so this first one right here, then that's the scatter plot, then this one over here is the corresponding residual plot. Notice that there's not a pattern to that residual plot. Okay, so this one right here, this first one, this one's a scatter plot that would have a best fit line, maybe something like that. And then the residual plot does not have, there's no pattern to this one. Okay, on the other hand, if you look at the second one, this one, the scatter plot is a curve, maybe like an exponential curve. And then when you look at the corresponding residual plot, you can see a definite pattern in the residual plot. This one also has a curve in the residual plot. So this one does have a pattern. Okay, and then here's another one, number 3. This one's also linear. So maybe the best fit line would look something like this. But notice the residual plot, this is very scattered. And has no pattern. Okay, so what the point of this was is that the more scattered, sorry. The residual plot the more scattered the residual plot, the more best fit best fit the graph will be to a linear So like in this case, this third one is more scattered. And if you look at the third graph over on the left side, it's closer to a line probably than the first one is. But both number 1 and number 3 have pretty scattered residual plots. When we get to lesson 19, the next lesson, we're actually going to talk about what we call a R value, or correlation coefficient, which it tells us exactly how good the scatter plot fits to a line. Okay, so what does it mean to have a curved pattern in the scatter plot or in residual plot? If there's a curved pattern in the residual plot, that means that the scattered plot is also curved. What does it mean when the points in the residual plot appear to be scattered at random with no visible pattern? That means that the scatter plot is closer to actually closer to a line. Why not just look? Sorry, I hit the smart button. I'm opening up a new smart book right now, which I did not want to do. Wait till it opens and then close it. Okay. Why not just look at the scatter plot of the original data? Why is the residual plot necessary? The next example is going to actually answer these questions. And I'll just kind of give you a hint. It's because sometimes you can be fooled. Okay, so why do we need the residual plot? That's what our next example is going to show us. The temperature in degrees Fahrenheit was measured at various altitudes in thousands of feet above Los Angeles. The scatter plot below seems to show a linear straight line relationship between these two quantities. So if you look at this looks like there's a linear relationship. It looks like we have a straight line here, or very close to a straight line. Of course, these are scatter plots, so they're never perfect. And that looks like there's a linear relationship there. So when we go to look at the residual plot, we're going to find that out. Remember, if the residual plot is more scattered, that's going to tell us if this is really a true line or not. If it's more of a curve, then that's going to tell us that there's really a curve in here that we're not seeing. Okay, here is a look at the residual plot. Do you see the actual curve in there? I do. Okay, so here's the actual curve. So what that means is that there was actually a curve that we didn't actually see. And there's reasons for that. Okay, this is a clear curve in the residual plot. So what appeared to be a linear relationship in the original scatter plot is in fact a non-linear relationship. How does this residual plot result from the original scatter plot? So how have we been doing? How have we been finding the residuals? So to find the residuals, we take and we first find the predicted values. Well, I guess let's back up. We have to find the equation of the best fit line. And then you have to find the predicted values. And then after you get the predicted values, then you have to find the residuals. which is the actual minus the predicted. And then finally you can graph the ordered pairs x, the original x's, and the residual as your y. Okay, so that was how we actually make the residual plot. Okay, exercises 1 through 3, volume and temperature. So water expands as it heats. Researchers measured the volume in millimeters of water at various temperatures. The results are shown as below. So here's some temperatures and the volume. We're going to use our graphing calculator and we're going to construct a scatter plot of this data. And we're going to include the least squares line. Remember, least squares line, that means the best fit line. We're just using new vocabulary. I guess it's not so much new anymore because they've been saying this for the last couple lessons. So the best fit line. And then we're going to make a sketch of the scatter plot, including the least squares line on the graph below. Alright, to make it easier for me, I'm going to get a copy of that table. Okay, so I'm going to show you something a little new today because I said to make the scatter plot in our calculator, which I have not shown you how to do yet. See, I've already made one. And I'm going to clean my calculator so I can start from scratch. So I can plot 712. Okay. Okay, so I want to take this table of values and I'm going to put them in my graphing calculator. That part we already know how to do. Go to Stat and enter. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And then over to L2, I'll put the next set of numbers, so 100.125, 100.145, 100.170, 100.191, 100.215. You'll notice that when I push enter, it looks like it's not putting the whole number there, but if you scroll back up at the bottom of the screen here, it really is holding that whole number there. It just doesn't have room for it, so it looks like it rounding it. Okay, I was at the 215, so 100.239, 100.266, 100.290, 100.319, and 100.345, and 100.374. Okay, I'm going to quit go out of this screen. Now to actually make a scatter plot in your graphing calculator, the next thing you're going to do, so this is the first new thing that you're doing, So this is to make plot in calculator. You're going to hit second and y equals, which some of the y equals keys I'm noticing are starting to fade away, but the y equals key is this very first key up here. And then we're going to pick number 1, so you hit enter. Okay, so I hit enter after that. And then notice how the cursor is blinking on the word on. I want to hit enter again so that it'll switch from off to on. So I'm going to hit enter again. And that's going to turn the plot on. Okay, and we don't need to change anything else. For type, it already is set up for a scatter plot. For X and for Y, it's already set up to use list 1 and list 2. Okay, so now I'm going to quit. So I'm going to hit second and mode to get out of this screen. And next, what I'm going to do to actually, that's to make the scatter plot. Now I want to see the scatter plot. Okay, so next thing I want to do is to view the plot. To view the plot, you're going to hit zoom and then the number 9 key. Okay, so zoom's up here. And then number 9, if you scroll down and look at what number 9 says, it says zoom stat. Everything that we do is about stats right now because we're doing statistics. And there's our scatter plot. That's what it should look like. Looks pretty linear, but it might be cool. Okay, so that's what our plot should look like. Move this out of the way somewhere. There we go. Let's put it down here. Okay, so that's what our plot should look like. Okay, so now I'm going to kind of mimic that on my graph right here. So 20 and 100.125. So here I've got 0.1 and here's 0.15. So 125 would be about halfway. The next one is 21 and 0.14. So that's going to be a little bit below 0.15. 22 is 101.7. So 1.7 is about halfway. 23 is 1.9, so that would be right below or about right below 0.2. 24 is 0.21, so that's going to be just above 0.2. 25, 100.23. So that's about halfway to 0.25. Whoops, off one. And 26, sorry, that's at 2.6, so that would be just a little bit above the 25. 27 is at 0.29, so it's going to be just a little bit below by 0.3 or 0.30. Okay, 28 is at 31, so that's going to be just a little bit above 0.3. 29, let's see, table out of the way here. 29 is at 3.4, so that would be just a little bit above 3.5. And lastly, 3.7, that's going to be about halfway. Okay, so that graph there should be approximately what this graph looks like here. And that was our table of values. Okay, so first of all, they said using the graphing calculator, construct the scatter plot, which I just showed you how to do. And now it says to include the best fit line. So let's find out what that equation would be. So I'm going to get out of here, so second mode, and we're going to get the equation just like we always have. So stat, go over to calc, and number 4. So that equation is y equals 0.02x plus 0.996. Now to see that equation on the graph, you would go to y equals, so that's this button up here, and just type in exactly what we see. So 0.02, x is right here next to the green alpha key, plus 0.996, and then hit graph. Hello, it's not graphing. Let's see, did I type it in right? 0.02x plus 0.996. Stat, calc, number 4, enter. Oh, I put the decimal in the wrong spot. That's why what's graphing. The decimal doesn't go there. The decimal goes right here. Okay, fix that. Those decimals are important. Okay, so let me go over here. Not too far. There we go. 99.6. There we go. Now hit graph. That's not the same spot at all. Really? My technology's not being nice to me today. Stat, calc, and number 4. .02 x 99.6. Equals 0.0002x. I don't know why. So now I'm starting to wonder, and that might be because it's not really a line at all. Okay, now it says using your graphing calculator, construct a residual plot for this data. Okay, let's see. Well, let's find out what our residuals would be. So we're going to have to add on to our table here. We're going to have to find our residuals. We know what our actuals are. Okay, we've got our x. This is our x. This is our y. We've got to find our, so y is our actual. We've now got to find our predicted values. And I'm guessing that line is not fitting it because it's not really a line at all. It's probably a curve, and we're not seeing it on the scale that was used. Okay, so let's find out our residuals. So to find our residuals, we need to plug into our equation. So let's take the 20 through 30 and plug in. And I'm going to show you how to do that fast. So since I already have the equation here, the 0.20x plus 99.6, let's go to, there's actually a table in the graphic calculator. I hit second and graph, and there's a table. And then I'm going to scroll down the table to 20. Okay, so there's 20, 21, 23. Whoops, I went a little too far. I want those other numbers, but I want to start with 20. Okay, so there's 20. So these are my predicted values. So my first predicted value for 20 is 100. My screen goes away if I don't bring that down. Then we've got 100. .02, 100.04, 100.06. That you can just about guess what the next number is going to be. They're going up by 200s. So I'm going to guess the next one's going to be, and that's only because the x values are increasing by 1. That you're seeing a pattern. So I'm going to guess, if I scroll down here, they're going to keep going up by, yep, so like that point 1 would be 0.10. Okay, so this one's 100.08, 100.10, 100.12, 100.14, 100.16, 18, and 100.20 or 0.2. Okay, but we need the residuals. So to get the residuals, we have to subtract the actual and the predicted. So I'm going to subtract those two numbers. So I don't need this anymore. So now I'm going to subtract. There's not a quick way to do that. I'm going to subtract 100.125 and 100, which is just going to be 0.125. Okay? And I'm just going to put those right next to my x because that's what I'm going to end up graphing. So right here, I'm going to put the residual. So that first one came out to 0.125. Okay, the next one is 100.145 minus 100.02. And that one's going to come out to .125. Oh, it is. And then 100.170. They all have 100, so we really want to subtract the decimals. So 0.170 minus 0.04. So 1.70 minus 0.4, or 0.04, excuse me. And that one comes out to 0.13. And then 0.191 minus 0.06. Now it's 0.131. And notice all these numbers are really close. And then 0.215 minus 0.08. I'm not putting the whole number in because they all have the 100, so that's going to cancel out. So 191 minus 0.06, 0.131. Oh, I was on 215, sorry. 0.215 minus 0.08. And that one comes out to 0.135. And you want to keep going, and then we're going to have to plot this. So on the x-axis, we're going to have from 20 to 30. So that would be 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. But on the y-axis, these numbers are really small. Looks like we have 0.12, 0.13, So I'm going to say like 0.10, 0.11, 0.12, 0.13, and so on. And I'm wondering if any of these are going to be negative. No, they're not. All of the numbers in the predicted are all smaller than the ones that are in the actual. So they should all come out to be positive. So then you would start plotting them, and what you're looking for is it scattered or is it a curve? If it's scattered, then we should be getting then that means that our original graph is actually a scatter plot. And if it's a curve, then that means that it's actually a curved graph, which would explain why that line was not actually fitting in. Okay, so for 20 so far, I've got 0.125, and then I got another 0.125. Then I got 0.13, 0.131, 0.135, and then let's see what's the next one. The next one would be 0.139. I have a feeling this is a curve, but upside down U is what it's looking like. Or actually, no, it's going to curve a little more differently than that. This is not going back down. The next one's going to be 0.14. Six. So that one's getting even a little higher. And the next one's going to be 0.150. So now it's getting higher. I'm feeling this is going to look kind of like an exponential curve. Next one's going to be oh, wait a minute. That's going to be 4. So it is going back down. Or is it? $159 is going higher. So that one's getting even higher. And then 0.345 minus 0.18. I think I'm going to make the graph a little different. 0.65. 0.374 minus 0.2. 174. Okay, so I'm going to make this axis over here a little different. They're all from 0.12 to 0.17. Okay, so we got 0.125, 0.125, 0.13, 0.131, 0.135, 0.139, 0.146, so all of a sudden like a big jump. 0.15, which is what's making me think it's a curve all of a sudden. Almost 0.16. Yeah, that's a definite curve. 16.5, and then 17. Or actually higher than 17. Okay, so that's a definite curve. Now that I included all the numbers, and you can see a definite curve in there. That's why the line, when I showed it, it says, do you see the residual plot? Do you see a clear curve in the residual plot? Yes. So what does that say about the original data? That is actually a curve. So even though the original data doesn't look like a curve, it looks like a nice line. is actually a curve also. So that's why when I have this graph up here, and then I made the line of best fit, it didn't really fit because it wasn't a line of best fit because it isn't really a line. Okay, so let's see if I can kind of approximate what that line of best fit should have looked like. So it's actually kind of almost where I have this one drawn. Let's see, 1, 2, 3, 4, about 5, almost 6 places over. So it's almost going about right, about 6 places over. It almost looks like it's going like this. Okay, so it didn't go through it because it's not really a curve of best fit. And again, tomorrow's lesson is going to actually be going over how well something fits, how well a line fits the data. It's called the correlation coefficient that we're going to go over next. Okay, so that's today's. So the big idea today was the residual plot shows you whether or not the actual plot is really a curve or a line.